Hi everyone, this is Mr. Zikri speaking. Today we are going to study about Transformer. It is not like a movie Transformer where Autobots fight Decepticon. Yeah, Transformer actually to transform one voltage to another value of voltage. So it's like a transformer in the movie, right? It's from the car trying to change into a robot. But in this case, we are going to study about transformer which can change a voltage of AC source into higher or lower voltage. So as you can see here, a transformer is consists of a coil, primary one, and then a secondary on another side. It is connected with this metal loop. So look at here in the picture. We are going to determine what is the magnetic field inside this metal loop at first. As you can see, because this switch is off, that means inside this loop there is no magnetic field. So, and then if we connect this switch or we close the switch, there will be current flowing through the coil, primary one. So inside this coil there will be magnetic field B. Because at first it is zero, so it will be opposed by B induction. This B induction will create I induction. This is called self-induction. So now look at the secondary. The B is created B, and then it will be opposed by B induction, and it will create current here, I induction. So although it is not connected directly, this coil is actually isolated and this coil also isolated. That means there is no current going through from primary to secondary. The means of this electric current is actually magnetic field changes. Yeah, so if this is in this coil, there is a magnetic field changing. Also in the secondary there will be magnetic field changing, so it will create current of induction in the second coil. So as you can see, in primary there is less number of turn of coil, but in secondary there is a lot of turns in coil. That means if I have another one, for example, let me put it like this. So if I have AC source 1 volt, so if I have one loop, that means in voltmeter it also will be read 1 volt. But if I have 2 loop, that means I have another 1 volt. If I change this into this, if I change it into another form, like this one. For example, this is AC source 1 volt, and then I have voltmeter here. So what is it rate? It will be 2 volt. Why? Because it has 2 turns of loop on the secondary. So that means the voltage will increase as the number of turns increase. So we can say V is proportional with N. N is the number of turn. So V1 over V2 equal to N1 over N2. V1 is primary voltage, N1 is number of turns primary, V2 secondary voltage, and N2 secondary number of turns. How about the current? How about the current? As you can see, if the coil increases, the turns increases. That means it becomes longer. If it becomes longer, it will have more resistance. That means it will oppose the current. So much more turns in coil, that means less in current. So this I2 actually less than I1 if the coil in secondary has much turns. So that means I1 is proportionally inverted with N1. So we can write it I1 over I2 equal to N2 over N1. Mister, so what is actually is being transferred? Oh, the thing that is being transferred here from primary to secondary actually power. So P1 should be equal to P2 if it is ideal transformer. That means V1 I1 equal to V2 I2, or we can say V1 over V2 equal to I2 over I1. So if the transformer is ideal, that means all the power from primary is transformed into power in secondary. Okay, how if it is not ideal? If it is not ideal, it has efficiency. The efficiency is actually a comparison between power of device at the secondary over the power of transformer in the primary. So as we can see here, the power of initial or in primary is Vi times I1, and primary and power in secondary is actually V2 times I2. So the efficiency could be from 0 to 100. Yeah, 0 means all the power is not being transformed into the secondary, or it becomes heat instead. Or if it is 100%, that means all the power is being transformed from primary to secondary. Now, as you can see here, we have two kinds of transformer. First one is step-up transformer. As you can see, the number of turn N1 and N2. Step-up transformer, it has secondary coil much more than primary coil, and then the voltage also increasing, and while the current is decreasing. And the second transformer, the second type of transformer is step down transformer. the number of turn in secondary has less number of turn in primary, and the voltage becomes lower, but the current increases. You have to write this down. You can pause this video and then we can continue to the next slide. For example, here a transformer has a primary coil consisting of 200 turns and secondary coil is consisting of 3000 turns. The primary coil is supplied with a voltage of 30 volt. What is the voltage in secondary circuit? So we assume that it is ideal transformer, so that means we can find out by using this V1 V2 equal to N1 N2. So what do we have here? This is the primary N1 and this is the secondary N2, and then this is the voltage of first or primary coil. So we can now solve this. 30 over V2 equal to 200 over 3000. As you can see, the number of secondary coil is greater than the primary coil, so V2 should be increasing, right? So V2 is actually 3000 times 30 over 200. We can cancel this. 30 times 30, 900 over 2, 45 or 450 volt. So as you can see, the voltage is increasing. Now the second question. A trafo has primary voltage 110 volt and secondary voltage 220 volt. Yeah. So let's say this is V1 and this is V2, and then as you can see here, the efficiency is 80%. So in primary coil there is a current of 5 ampere. What is the current in secondary? So as you can see that the efficiency is power on secondary over power in primary. Efficiency here given 80% or 0.8, while the power is V1 times I1, in this case 2, and V1 times I1. 0.8 means 8 over 10 equal to 2. Let's continue again. I'm so sorry. So V2 here, 220. I2 is being asked. V1 is 110, and I1 is 5. So we can cancel this one, and we have here 2. So we can like make it I2 is actually 5 times 8 over 2 times 10. So it's like 40 over 20. It's 2 ampere. Next question is about also transformer with the same principle as the previous example. Here a transformer is being connected to AC voltage of 200 volt, that transformer is used to run on 12 volt AC. Transformer has efficiency of 90%. So to make the electrical devices runs normally, the source of voltage should supply 2.5 ampere. What is the power of the source? Yeah, the power of the source. I don't think it's the power of the source, but it's the power of, the power of the device. I'm so sorry, the power of the device. This is device, yeah, electrical devices. So to find P2, actually, to find P2, we can use efficiency formula, P1 over P2, as we know that P2 means so sorry, this is not like that. P2 over P1. So P2 actually efficiency times P1. Efficiency 0.9, voltage 1 times I1. So 0.9 times 200 times 2.5. What do we have here? P2 equal to what is it? 180 times 2.5. So it's 450 watt. Next, here we have all the information. We have the information of efficiency 80% or 0.8. We have primary voltage and secondary voltage. We have power output. And now, what is the current in primary? So as you know that efficiency is P1 over P2, P2 over P1, P2 over P1, it's 0.8. P2, we know that it's 24. P1 is P1 times I1. So it's P1 times I1 equal to 24 for 0.8. This is 120 I1. This one 30. So I1 is actually 30 over 120, 0.25 ampere. Next, how about this one? What is the output potential difference from the secondary coil of the transformer on the right? 240,000 volt, 100 turns. So here becomes 50 turns. So it becomes half of them, and then do not forget to change. So as you can see here, from 1,000 to 50, it decreases. It decreases like 1 over 20. Yeah, 1 over 20. 1 over 20. So it will become this one. And then as you can see here, from 600 turns to 20 turns, it decreases 1 over 30. 1 over 30. So it becomes 400 volt. I will not show you this process, but you can do by yourself by using this. I would like to see on your book that you are using this instead, okay, on your notebook, please. Tomorrow you should write the process using this. I'm showing you the result, but I want you to write down the process by yourself. Next. Yeah, it finished. So next time I'll give you the exercise, and then you'll be prepared. You'll be preparing for final term exam. Okay, guys, do not forget to like, comment, subscribe, and share. See you guys. Bye bye.